So when you have graphs, we like to look at how the graph has possible symmetries. Now, not every graph has a symmetry, but some do. So one type of symmetry that we talk about is symmetric about the x-axis. We say x-axis symmetry. Let's say we have a graph that looks like this. If it would be symmetric about the x-axis, we could test for symmetry. If it looks exactly the same and it mirrors within the x-axis, so the x is a mirror. So it's as if you're looking through like a light and you see it goes through. So if this was the actual graph itself, the red and the blue together is one line. Now notice that's not a function because it doesn't pass the vertical line test. But a graph is symmetric with respect to the x-axis if every point xy on the graph, the point x negative y is also on the graph. So I'm going to write that. So a graph is symmetric about the x-axis if for every point xy on the graph, the point x negative y is also on the graph. Let's try an example. Let the point 5, 3 be a point on the graph. If the graph is symmetric about the x-axis, what point must also be on the graph? Well, remember, if xy is on the graph, then the point x negative y must be on the graph. So 5, 3 is here. If it's symmetric about the x-axis, the other point should be here. The second type of symmetry is y-axis symmetry, and this is more common when we talk about functions because we would think of something like our parabola. The equation y is equal to x squared is symmetric about the y-axis because the y-axis acts as a mirror. And whatever point is on here is also across that y-axis. So the definition is a graph is symmetric with respect to the y-axis if for every point xy on the graph, the point negative xy is also on the graph. Remember, if this is an x value, then this is the negative x value of it. The third type of symmetry is symmetry with respect to the origin. Now remember, the origin is the point 0, 0. It's where the x and the y-axis meet. The definition is a graph is symmetric about the origin if for every point xy on the graph, the point negative x negative y is also on the graph. So if we think about it in terms of here, let's see, we have the point xy right here. We want it to be reflected through the origin. This is its line where it's reflected through. That's its mirror. So the corresponding point would be here. And that would be negative x, negative y.